Hi, this is Mr. Ruger. Sorry, the video kind of cut out on me because I ran out of storage, so I had to delete some stuff. But I did want to take a look at a couple things that you guys might want to take a look at when you are actually graphing, studying for your quiz, graphing, things of that nature. So, you have a quiz tomorrow. You've already talked about exponential graphing. So let's take a look at, we have growth, we have decay, we have compound interest, we have half-life, and we have solving rational equations. Those are the things that you will see on your quiz tomorrow. I'd like to say that that simplifying radicals will be there. You may have to see them, you maybe have to be comfortable with them, but specifically saying, tell me what the square root of 80 is in its simplest radical form, I'm not going to do. So it's going to be important for you to remember that for all growth decay functions, they follow this y equals a times b to the x. And specifically for growth, our b is going to be 1 plus r, and that r is going to be a rate. It's going to be a percentage. Now that percentage, you have to convert it to a decimal. How do I convert percentage to a decimal? You take the number, divide it by 100. That's what will give you your decimal. That will be the rate that you're talking about. Decay, the only thing different about the decay is that it's going to be, instead of 1 plus, it's going to be 1 minus r. But same idea, that r is the rate, and we take the rate by taking the percentage and dividing it by 100. When we talk about interest, our interest, we have simple interest, which is I equals P times R times T. There's nothing really special about that. You have compound interest, which is going to be P, which is your principal, plus, then we have 1 plus your rate over the number of times it compounds, times N times T. Remember, N is your compounding rate, and then T is your time, and then R is, once again, your percentage. If it's quarterly, please make sure that you put the 4 here as well as up here. You've got to put it in both places, or else you're going to get some pretty skewed answers. Or continuous interest, that is going to be P to the E or P times E to the RT. That E, remember, I find that by pushing second and then natural log on my calculator. It's in the light blue right above natural log, and that's where you could find that. But you're simply typing all that stuff in. Remember, when it comes to RT, make sure that you use parentheses for both R and T, or else your answers will get a little wonky again. Half-life. Half-life is always going to be the initial amount, and then it's always going to be a half. That's why it's called half-life. So that's always a half. And then that's going to be over the x, which is your time, and then the half-life that's on the bottom. So if it has a half-life of 8 days, you're going to put your 8 down here. Okay? That's where that goes. When it says things like half-life of whatever, that's what goes in the denominator. Last thing we have to talk about is solving rational equations. And the big thing about solving rational equations is to check for extraneous solutions. Remember, you are going to have to square both sides. There probably will involve some factoring. And when you get done with that, you're going to end up with 1 to 2 answers that you're going to have to check for extraneous solutions. What does that mean? That means that when I plug the answers back into the original equation, you get something like 5 is equal to 3. 5 is equal to the square root of negative 25. That can't happen because you can't take the square root of a negative. Negative 11 is equal to the square root of 121. Once again, that's not going to happen. Yes, it is true that when you're solving an equation, that x equals the square root of 121. X could equal negative 11, or x could equal positive 11. The question is now you're setting up an equivalency statement between, it's a test. So now you're saying, is the left side the same as the right side? Which means that you're testing two expressions. And so when that's the case, you take the square root of 25. The answer needs to be 5. But you know, if you get something like that, then obviously they won't work, and so those answers will be extraneous. I can give you a quick answer or a quick example before we say our goodbyes here. So if I were to say n equals, say, the square root of 2n minus, oh heck, I don't know, we'll say 8. That should work. First thing we do is we square both sides. So n squared is equal to 2n minus 8. I move everything over, and I end up with n squared is equal to 2n minus 8, sorry, add 8, subtract 2, subtract 2n, and add 8 over here. So we end up with n squared minus 2n plus 8 equals, well, 0. Sorry. This one's going to get a little bit wonky because this guy is not factorable. So when I said that it should work, I was wrong. So what have I got to use? Well, I can do two things. I can either move my 8 over and back to where it was and say n squared minus 2n equals negative 8 and complete the square. So you can certainly do that. Divide this by 2 and square it, and you're going to get a positive 1. Add 1 to both sides, and so n squared minus 2n plus 1 is equal to negative 7, which gives me n plus 1 quantity squared equals negative 7. And as you can see, once I take the square root of both sides here, n plus 1 is going to equal plus or minus the square root of negative 7. That can't happen. Both of them are going to be extraneous, and so there are no solutions to this whatsoever. Bad example, but we're running short on time. So if you have any questions, stop back in and see me this Friday morning before your quiz, and I'll see what I can do to help you. Have a wonderful day.